the last lesson, the new stuff. The last part of today's lesson, lesson 2, the new stuff for the day. And the definition of a linear equation, blah, 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 A, B, and C are real numbers. And basically they look like this. AX plus B equals C. Now, an example would be 4x plus 2 equals 6. This is a basic, very fundamental two-step equations that most students start to see when they're in 6th grade, certainly by 7th grade. Okay? Okay. So this is a very formal math geek kind of definition that a linear equation looks like AX plus BX plus C. What exactly is an equation in terms that we can relate to, not necessarily a math geek definition? Well, an equation is a search for something that makes it work. For example, with 4x plus 2 equals 6, we're looking for the one and only one value in the world for which 4 times that value plus 2 is equal to 6. And you know, there's an infinite number of values out there. It could be 1, 2, 3, 4, the negatives, halves, quarters, decimals, irrational numbers. But in a linear equation, which means an exponent of 1 on the variable, which in this case is the x, in a linear equation, there's only one solution. So I like to ask kids, what's the internet? What exactly is the internet? Well, where is the internet? And the internet is not some, you can't go to some place and like open a door and say, aha, I found it, there's the internet. The internet links all of the websites that are out there flying around. For example, I have one, fliesforfish.com for fly fishing, and we'll be having one shortly, riversrestkennel.com for our miniature Australian Shepherds. Now, if you wanted to Google miniature Australian Shepherds, you could go into Google, do a search, and type in miniature Australian Shepherds. But if you wanted to find our specific kennel, then you would have to scroll through the possible kennels out there and limit it to our one and only one kennel that has those particular solutions. Okay? So with a linear equation, there's one and only one answer. Now, your job as the person solving the equation is to find that answer. So I put a map up there, and that's a map of Long Island. I was born and raised on Long Island. I was born and originally lived in the Babylon area for, I guess till I was about 9 or 10 years old, about 10. And then we moved to Bayport, Long Island, which is right next door, actually Blue Point. Bayport, Blue Point is one community. Right next door to Patchogue, which is highlighted here. And then I taught at Patchogue, Medford for 33 years. And I always had something very, very strange happen when I taught at Patchogue, Medford. And you never know how things are going to come along. When I was in college, I read this book. It was called Fatal Vision. And it's one of maybe 2 books in my entire life that truly scared me. The reason it scared me is that this book was about a person who was from Patchogue, which was the town next to the town that I lived in. Oddly enough, I wind up teaching not only for the school district he went to, but in the very school that he attended, and I probably taught in classrooms that he was in, and it gets even better in a little bit. So here's what happens. There was this guy by the name of Jeffrey McDonald, and Jeffrey McDonald was a Green Beret, and he was like the all-world boy. Jeffrey McDonald was the starting point guard on the basketball team, the starting quarterback on the football team, a pitcher and the shortstop on the baseball team. He was the valedictorian of his high school class, and he dated the head cheerleader all through high school, a young girl by the name of Colette Kassab. And between the two of them, they were the high school sweethearts that were voted most likely to get married. And this is the classic all-American type of love story in young people that we all like to, watch on Lifetime Channel or Women's TV channel. So they get along great. They get along fantastic. High school sweethearts. They go get married. McDonald, being so intelligent, actually attends, I believe it was Columbia University in New York City, to become a doctor. And then he went to medical school at Northwestern, another really good school. He graduates from there, becomes a doctor, and then he feels, this was around the time of Vietnam, he felt it was really important to fight for his country. So as a doctor, he enlists in the military and he becomes a Green Beret. He was the trainer for the U.S. Army boxing team. He was a Green Beret, which a Green Beret is the Army equivalent of a Navy SEAL. Okay, really tough guys, trained to kill with their bare hands, brilliant, which McDonald definitely was. And he had this apartment on Fort Bragg, and a murder supposedly took place in here. You see, what happens is Jeffrey McDonald claimed that a bunch of drugged out hippies broke into his house, that he fought with them, that they knocked him unconscious, and he was stabbed multiple times, like 6 times, but every stab wound was generally superficial and in places where it couldn't do any serious damage, which of course a doctor would know. And he said that there was this girl named Helena Stokely, and she chanted incantations while these other hippies beat him up, knocked him unconscious, and then they went down the hall and they butchered his family. And when I say butchered, I mean butchered, like sliced his family to pieces and stabbed him with ice picks. It was really horrific. And generally speaking, everybody thinks McDonald is a really nice guy, so they generally believe him. But some things happened at this time. If you've ever heard of Charles Manson and the murders out in California and Helter Skelter, it happened just before this. And there were actually magazines in his living room about the Charles Manson attack. So some people felt that McDonald did the crime and that he was just trying to copycat off of the Charles Manson murders. And some people said, no, he would never do it. And one of those people who said he would never do this, he said he's known him since he was a little boy, was his wife Colette's father, Fred Kassab. He said, no, you don't know this guy. This guy's like gold. He's really, really good to her. It did come out afterward that he cheated on her once or twice, but he said he's still a really good guy who can never, ever kill his wife and his young daughters. That's not going to happen. So he got tried in the military. And kind of like with the O.J. Simpson case, the claim was that he botched, or the police botched, the evidence, and he winds up being acquitted. And then Jeffrey McDonald starts going on all the talk shows. Now, nowadays we have like Dr. Phil and Oprah and Ellen. Back then they had Dick Cavett, Phil Donahue, and a bunch of others. He starts going on all of these shows, and Fred Kassab is listening to him. And Fred Kassab, remember, that's his dead wife's father. He's getting really upset. I mean, if your family's butchered, why are you going on TV talking about it all the time? And he was kind of like happy on these shows, like he liked the attention. So the father starts getting really upset. And then he starts noticing that on all of these shows, what McDonald is saying is there's little differences on each show. So McDonald's like, well, that's not what he said on the other show. So, not McDonald, I'm sorry, Fred Kassab is like, it's not what he said on the other show. So he orders a transcript of everything said at the trial, and he starts going through it, and he's circling with a highlighter all of the times that McDonald contradicted himself, and the lawyers never picked up on it. So Kassab is torn at this point. He's like, no, I couldn't do it, but he said these things, and they kind of indicate that he did. So Fred Kassab flies down to Fort Bragg, North Carolina, and he goes into the murder scene, which you're looking at a picture of right here, or at least the living room of the house. The murders took place in the bedrooms. And Fred Kassab is getting so frustrated that he doesn't know what to do, that he walks around that kitchen, the living room that you see right there. He walks around in circles, and he gets so mad, he picks his right foot up and he stomps it as hard as he can against the ground. And you can't see it in the picture, but there was a mantle up on the wall with a bunch of birthday cards to one of the little girls. And all of the birthday cards fell over. And Kassab said, you know what? He did it. He did it. He did it. He did it because there's no way in the world that he possibly could have had this life and death struggle with these four hippies and not had the birthday cards fall over. I mean, look, the coffee table is knocked over. There were other stuff knocked around the living room. He staged this scene. If he really truly did it, those cards would have fallen over too. So McDonald went and got tried a second time, this time in civil court, public court, and he was found guilty. And I don't know if he has yet died or if he's still alive, but he spent the rest of his life, as far as we know, in jail, and I don't think he's going to be getting parole anytime soon. So that would be the end of the story, except I had this family that I taught. I taught all the girls. I think there were 4 of them. And I would always tell this story about introducing what a solving an equation is like. Solving an equation is like finding the perpetrator, finding the person who did the crime. Think of that as the variable. You got to figure out who it is, and you got to be like the police, and you got to go to like the crime scene in the upper right-hand corner, and then you have to work backwards with the crime, kind of like Fred Kassab did, and then you have to see if you can get it down to one suspect and prove that that one suspect or that one number is actually the value that works. So, like I said, I taught this introduced equations this way for many, many, many years. And one day I'm telling the story in class, and one of the girls in the back of the room, one of these young ladies whose family I worked with, she raises her hand and she says, "Mr. Lindquist, my family bought the house that Colette used to live in." And now, let's be clear, these murders took place in North Carolina. They did not take place in Patchogue. She says, "My bedroom is Colette's old bedroom." So, like, how spooky is that? That her bedroom is the one that used to belong to the murdered girl. Ooh, kind of freaky. Okay, so when we see a linear equation like 4x plus 2 equals 14, this is what we should not do. We should not say, 4 times what number, then add 2 is equal to 14. Oh, yeah, that approach works for the easy ones like this. You could say, well, 4 times 3 is 12, plus 2 is 14. And it would work for this, but when you get to the tough equations, say something like this guy, well, then we don't walk around with those numbers off the top of our head. So we need a strategy. We need an algorithm, a way to go about solving these equations that will always work. We want to be like a detective at a crime scene. Okay. I don't know why this is happening. Here's the detective at a crime scene. It is Detective Columbo. One more thing, and if you have ever seen the TV show Columbo, then you understand what I'm talking about. All right, so here are 3 two-step equations. Let's do the first one together, then I'll leave you on the next 2 to do one at a time. And again, you should be pretty comfortable with these, as you did a lot of these when you were younger in school. So the big process we use here, the strategy, is we want to undo. We want to do the inverse or the opposite of each of the operations, kind of like stomping our foot on the floor. So this says minus 4. We do the inverse of the order of operations. We would normally do addition and subtraction last, so now we're going to do it first. It says minus 4, we do plus 4. That's step 1. Now minus 4 and plus 4, they cancel each other out. That's why we chose the plus 4. So on the left-hand side of that equal sign, I still have 5 x's. And on the right-hand side, 36 plus 4 is 40. So I asked myself, what is happening to that x? Well, it's being multiplied by 5. So the opposite of multiplying by 5 is dividing by 5. And that gives me x is equal to 8. 40 divided by 5 is 8. Now, this is like coming up with the suspect. And now we have to check and confirm that the suspect's actually guilty. 5 times 8 is 40, minus 4 is 36. So our basic strategy is to do the inverse of the opposite of each of these steps and arrive at a single value that could have done it. You try the second one. Go ahead. Remember, stop and start. Okay, so step 1, we do the opposite of minus 3 and we add 3. So that gives me negative 9n or x, I switched them here, sorry, equals 18. Dividing by negative 9, and I get x is equal to negative 2. 18 divided by negative 2 is, negative 9, sorry, is negative 2. And, just checking that this person actually did the crime. This is your trial here. Negative 9 times negative 2 is 18. 18 minus 3 is 15. Booyah, definitely got it right. Next one up. Now notice this time it says D over 4. That means D is being divided by 4, and at some point you're going to need to do the opposite of dividing by 4 and multiply by 4. Go ahead. Okay. So, first it says plus 3, so we do minus 3. And on the left-hand side, I did not touch the D over 4, so it's still there. And you could look at the right-hand side as you do negative 2 minus 3, but I prefer to look at it as, I'm just going to add, and the sign in front tells me whether it's positive or negative. So I have negative 2 and negative 3, and negative 2 and negative 3, all added up is negative 5. Now I need to do the opposite of divide by 4, which is multiply by 4, and that gives me D is, or X is, negative 20, whatever the variable is. Okay. 2. I don't know why this isn't going here. All right, I'll do this. Okay. Now, rarely are things that easy. More often they begin to look like this. Okay? And when they begin to look like this, it's a little bit more challenging. And the key is to know what process to follow. And now you become part Detective Columbo, part Peyton Manning. What we like to say is that if you ever watch football, the quarterback comes to the line of scrimmage and he'll start saying things like blue 21, set, 15. And what the quarterback's doing is he's looking at the defense and he's figuring out, is the play that they have called on offense, does it have a good chance to be successful against this particular play? Or is it, not going to be successful? So you want to make sure that you have the right strategy for each play. For example, if the defense puts all of their players right in front of the quarterback and right over the center, and the quarterback calls a handoff to run the ball right up the middle through the quarterback and through the center, it's probably not going to work because there's going to be 11 players there to stop it. But if he looks up and he says, you know what, I have single coverage with a linebacker against the wide receiver, you want to, throw that ball to the wide receiver because there's a really good chance the wide receiver is going to get open. Okay, so what I notice on the left-hand side here is that the variables are on the same side. And whenever they're on the same side, it's going to be same operation. That's how you do it. So if you were Peyton Manning coming to the line, or Zach Wilson for the Jets, or Daniel Jones for the Lions, you would look at the equation and go, same side, everybody, same side. And the team would check back and say, same operation, telling you what to do. Okay? So since the 5x and the 3x are on the same side, you just do that same operation. 5x's plus 3x's are 8x's. Now it looks like those standard two-steppers we just did. So now we know what to do. We add 9 to both sides. We get 8x's negative 16. Then we divide by 8, and I get x is equal to negative 2. And that's the one and only one number in all of Numberland that satisfies this particular linear equation. And that's what we're looking for. We're looking for, just like before, we looked for the one website that worked. Now we're looking for the one number in all of Numberland that works. Okay, so we look at the next equation, and the first thing I notice is, I better distribute. So 2 times 2n is 4n, and 2 times negative 5 is negative 10. Now I'm Peyton Manning, part Columbo, and I look at this and I notice that now the n's are not on the same side of the equal sign. They're on opposite sides of the equal sign. So instead of yelling, same side, same operation, I'm going to say to myself, opposite side, opposite operation. So I see that the variables are on the opposite side, so I do the opposite operation, always beginning with the letters. So the n's are on opposite sides. Remember, peek in front, this n is a positive n, so I do the opposite, which is minus n. And that gives me 3n minus 10 is 11, adding 10 to both sides, because now it looks like a standard two-stepper, and we know what to do. 3n is 21, dividing by 3, n is 7. So really, whether we choose by looking at the problem to do the same side, same operation, or opposite side, opposite operation. And if you choose wrong, you will get the problem wrong. But if you recognize the right strategy and you do it, after one step, it looks like those really simple ones we just did a minute ago. So your job is to do one step and then make it simple. Okay. Come on. I don't know why this is doing this, but for some reason, it's re-emphasizing all of these things. I don't know why it's doing that, but it is. Okay, try these two. We'll stop and start, and then I'll give you the answers. Go ahead. Okay, so I look at the one on the left, and I ask myself, is this the same side, same operation, or opposite side, opposite operation? It's the same side, same operation, so that gives me 9 H's minus 9 is equal to, and then notice that the 23 and 4 are on the same side, so that would become 27. And also, I gave you 4 choices for answers. 2 of them don't solve either equations. Which are they? We'll figure that out at the end. So again, 5 H's and 4 H's are 9 H's. I didn't touch the minus 9. And 23 plus 4, because the numbers can be on the same side too, not just the variables, is 27. Adding 9 to both sides, 9 H is 36. Dividing, and I get H is 4. So now I know of those 4 choices, one of them is indeed 4. Okay, next up. First distribute to 3. Anytime you see the number outside the parentheses, you want to do that first. Now we look and we notice that the K's are on opposite sides of the equal sign. So opposite side, opposite operation. Always start with the smallest number of K's. So I'm not going to subtract 7K. It's not about left, right. It's about the smallest number. I'm going to subtract 3K's. And there's a danger moment here. You know who was like kind of heroic to me that I really loved watching his shows on Animal Planet and a long time ago. I'm not sure if any of you watched him. This guy named Steve Irwin. Great guy. And he'd like pick up some black mamba or rattlesnake or copperhead or pit viper, and he'd go, danger. This is the second most deadly snake in the whole world. One little bite from this beauty, you're a goner. That's what he would say. And to me, danger. This is the second most deadly type of math problem in the whole world. One little bite from this beauty, you're a goner. See, you got to be really careful. Right here, this 15, this is a negative 15. So yes, do the opposite with the 3Ks, but you can't just write a 15 down here because you'd be changing it from a negative 15 to a positive 15. Remember yesterday we talked about, or our last lesson, we talked about how you tell the difference between Mr. and Mrs. Lindquist, whether you talk about the boy or the girl. You got Lindquist, you look in front. Mr. means the male, Mrs. means the female. So the 15, you look in front, positive or negative. In this case, it's negative. 4K plus 1, subtracting 1 from both sides. Negative 15 and negative 1 makes negative 16 equals 4K. Dividing by 4, because 4K means 4 times K, so I need to do the opposite, and K is negative 4. So the 2 of these that work are 4 and negative 4, and the 2 that do not work are 36 and negative 36. Okay, try this one. Simplify each side, and then see what you get. Okay, so I do assume that you can stop and start. On the left-hand side, those 9x's minus 4x's will give you 5x's. And on the right-hand side, you can get the positive 1, remember that's positive, and the positive 14 to make 15. So 5 plus 5x, because 9x's minus 4x's is 5x, equals 15, we just mentioned that, minus 5x. So we said before, you always start with the smallest number of x's. Negative 5x is the smallest. So we add 5x's to both sides. That gives me 10x's. Then this 5 here is positive, peeking in front. I don't care about this plus afterwards. I only care about what's in front. In front is the unwritten positive sign. So I do minus 5 and minus 5. That gives me 10x is 10. Dividing by 10, x is equal to 1. If you wanted to check it, 5 plus 9 times 1, because we think this answer is 1. We're proving it in court now. Minus 4 times 1 equals 1. Minus 5 times 1 plus 14. So I'm just substituting the 1 in for an x everywhere I see an x. And then doing a little evaluating here. 9 times 1 is 9. 5 and 9 make 14. 14 minus 4 is 10. And on the other side, negative 5 times 1 is negative 5. 1 minus 5 is negative 4. Plus 14 is 10. 10 is equal to 10. Okay. In case you got that one wrong, let's try another one very similar to it. Good. Okay, so I want to get my variables together on the left. I want to get my numbers together on the right. Same side, same operation. If I do that, I get 5 minus 1x equals 13, because 12 and 1 make 13, minus 2x. So again, start with the smaller number of x's. In this case, the smallest number of x's is negative 2x. So I add 2x to both sides, and I get 5 plus x is 13. Then I subtract 5 from both sides, and I get x is equal to 8. Okay? All right, let's try another one. Well, there's your check to show that it actually works, which it does. Negative 3 is equal to negative 3. Okay. I actually took this out of a college textbook, so don't forget to distribute and then check. Is it same side? Is it opposite side? Go ahead. Okay, so distributing the negative 2, I get negative 6x plus 2. Remember, a negative 2 times a negative 1 is a positive 2. Plus x is 14 minus x. Let's get our x's together here. Negative 6 plus 1x is negative 5x. They were on the same side, so I wanted to do the same operation. Always start with the smallest number of x's. That's the minus 5x, so I'm going to add 5x to both sides. And I get 2 is equal to 14 plus 4x. Now, what kind of 14 is this? This is a positive 14. Subtracting 14 from both sides, I get negative 12 is 4x. Dividing by 4, x is negative 3. Okay. All right. Next question's up. There's a relationship between the number of words in the child's vocabulary, V, and the child's age, A, in months for ages between 15 and 50 months, inclusive. This relationship can be modeled by the following formula. So V, in other words, the number of words in the vocabulary plus 900 is equal to 60A, where A is the age. Use the formula to find the number of words in the child's vocabulary at age 50 months. So you just substitute the things into there. So you want the words, which is V, and then the age is 50 months. So we substitute nothing for V because we don't know what that is, but we substitute 50 for A. And I get V plus 900 equals, and then 60 times 50 is 3,000. And I tend to write or shows work vertically, but this is just horizontally. It said plus 900, so the person who solved this did minus 900 to both sides, and V is 2,100. So that means at 50 months, a child has a vocabulary of about 2,100 words, which is most impressive, considering all. I think if we think about the number of words we know, we're not exactly sure if we hit 2,100 words. Okay. Just real quick, on the left-hand side, 5x equals 20, you know that you should divide by 5. But on the right-hand side, if we say 2/3 W equals 8, there's two ways we can handle this. One way is to understand that when we divide a fraction, we really flip and multiply, okay? So I can do that in my head. I can flip 2/3 to 3/2 and multiply both sides by 3/2. Or, nowadays students use calculators all the time, so you can just divide both sides by 2/3. The way you would do it on a graphing calculator is you do 8 divided by, and then you hit alpha y equals, and you'll see the box comes up with fraction choices. Choose the one that looks like a fraction, and then put in 2/3, and then hit enter, and you'll get 8 divided by 2/3, which is the same thing as 8 times 3/2, and you get 12 as the correct answer. Okay, another example. Go ahead, give this a try. Okay, so again, this time it's opposite side, opposite operation. We're going to add 4x to both sides. That gives me 6x minus 15 is 21. Add 15 to both sides. 6x is 36. Dividing by 6, x is 6. Okay? All right. The bar graph shows the inflation-adjusted price of a Westie puppy in 1940 and again in 2009. And certainly this is before the current inflation-adjusted price. Using today's dollars, the data can be described by the mathematical model. So here's the equation, and this is the thing that matters. P equals 18N plus 765, where P is the puppy's price N years after 1940. Does the formula underestimate or overestimate the price of a puppy? By how much? So what you want to do here is they're spending $2,000 for a puppy. Okay, so you want to plug in the 2,000 and see what you get as your solution. So according to them, N should equal 69, which would be 2009 minus 1940, because that's the number of years since 1940. And the price should be 18N plus 765. Since the number of years is 69, 18 times 69 plus 765 is $2,007. So it's a slight underestimate by about $7. If the trend given by this formula continues, when will the price of the puppy be $21.51? So now you're going to go back to your formula here, P equals 18N plus 765. You're going to plug in a $21.51 for P, because that's the price. Solve for N, see what you get. Go ahead, give it a try. I'll give you the answers in a moment. Don't forget to stop and start. Okay, 2151 equals 18N plus 765. Subtracting 765, I get 1836 is 18N. Dividing by 18, I get N is 77. But don't forget, these are the years after 1940. So 1940 plus 77 is 2017. So that's the year it'll cost it. Okay? What's the procedure for solving linear equations? The procedure is same side or opposite side. Ask yourself that question. Work toward becoming a standard two-stepper. Isolate the variable and solve. Check the proposed solution in the original equation. So that's what they do here. First, they distribute. They distribute the 4 and get 8x plus 4. They distribute the 3 and get 6x minus 15. Then they have opposite side, opposite operation. So you subtract 6x from both sides. Again, they just did it horizontally as opposed to vertically. And then they add the 25 to both sides. Then they divide and they get x is 5. So this is very much what we've been doing, with the one exception that they write horizontally and we've written vertically. So now the last thing we're going to do in class is these 10 equations, and you're going to do them now. I'm going to pause the video for just 1 second. You're going to do them, come up with the answers. Then I'm going to show you the answers that I wrote out step by step on the next page, and you can do that. If you have any problems when I show you the answers, you can seek help from another person in the class, help from me, and we'll get you straightened out. Okay, do these. Okay, I assume that you are done with all of these. You should have just frozen the screen. And then here's your answers. And you can just freeze the screen. I was going to say squeeze the frame. Freeze the screen. Freeze the screen for these solutions. All right, take care. Bye.